Hello, welcome to tutorial 7, Mapping Models to Code. Question 1. Refer to the analysis model developed in question 3 of tutorial 3 and question 3 of tutorial 4. For each arrival shipment, the elevator manager enters shipment information. The system then attempts to generate an allocation plan automatically. So question A. Specify allocate shipment operation of auto allocation manager, including signature pre-post conditions. Now let's go back to the requirement. We can see that the elevator accepts shipments of wheat, barley, long grain rice, short grain rice, oats, and hops. Each type of grain has two grades, high and low, and each truck carries between 150 and 180 bushels. So for the allocate shipment method, it accept the input type, grade, and quantity. So the precondition is that the type must be one of wheat, barley, long grain rice, short grain rice, oats, and hops, and the grade must be either high or low, and the quantity is between 150 to 180. The post condition is an allocation plan is generated for confirmation. We actually have a better interface specification for the method allocate shipment. We can specify the type and the grade as a enumeration type instead of the general string. And by using this way, the parameter type already constrains what valid values can be. There's no need for specific preconditions for type and grade. So for the quantity, the precondition is still 150 to 180, and the post condition is an allocation plan is generated for confirmation. For question B, who will enforce preconditions? We have two alternatives here, so we look through one by one. For the alternative 1, the preconditions can be checked by the control object allocation manager. After the elevator manager enters any values in the incoming shipment UI, the allocation manager receives the shipment information from the UI and checks the validity of shipment information. So if the input is valid, the allocation manager can proceed. Otherwise, the allocation manager will prompt to the elevator manager to correct the erroneous inputs. So for this alternative, the advantage is the validated checking is centralized. It can check complex preconditions involving a few input values. The disadvantage is that it's less user-friendly. There may be network overhead if the allocation manager is deployed on a remote server. For alternative 2, the precondition checking can be enforced in incoming shipment UI. So, for example, we can use the drop-down list for the user to only select valid green types and green grades. We can ensure the input for quantity must be numbers and must be within 150 to 180. So for this alternative, the advantage is that it can guarantee the validity of input values. There is no need for the allocation manager to check the data. It's more user-friendly. It can correct the input errors immediately. So the disadvantage is that the validated checking is done by individual input fields, so it's difficult to handle complex the preconditions involving a few input values. Question 2. Assume you are building a module management system for a university. A module is taught by a team of instructors and coordinated by one of those instructors. Each module has exactly one coordinator. The maximum number of modules an instructor could be teaching is 3, while an instructor is not allowed to coordinate more than 2 modules at a time. A module has one or more tutorial groups. Each tutorial is taught by only one instructor. Question A. Draw class diagram representing domain concepts and their associations. So first, let's identify the class first. We can see that there's a module, instructor, coordinator, and the tutorial groups. Actually, the instructor and the coordinator is one class. They are all teachers, plus different roles. So we can come out this model like this one. We have module, instructor, and tutorial. There is a relationship between instructor and the module. The role in at the side of instructor is a coordinator, and the role of module is a coordinator module. The multiplicity at the side of instructor is a 1, and the instructor can coordinate at most the 2 modules. So the multiplicity at the module set is 0 to 2. There is also a relationship between module and the instructor. The multiplicity at the side of instructor is a 1 to many. As instructor can teach at the most 3 modules, and the multiplicity at the module set is 0 to 3. There is a relationship between module and the tutorial. It's actually an aggregation because a module has one or more tutorial groups. So a module, so the multiplicity at the tutorial side is 1 to many, and the multiplicity at the module side is 1. Each tutorial is taught by only one instructor, so there is a relationship between tutorial and the instructor. We can see that the multiplicity at the instructor side is 1, and the tutorial side is 0 to many. Question B. Map the class diagram to code as the source code needed to maintain reference integrity. So the code is like this one. The key point is here. In the class of tutorial, there is a module and a tutor. Because a tutorial belongs to a module and the tutorial is taught by one tutor. For the class instructor, it has the set taught modules, the set coordinate modules, and the set taught tutorials. For the class module, it has only one coordinator. It has a set of teachers who are class of instructor and a set of tutorials. For question C, map the class diagram to a relational schema. First, we have module, instructor, and the tutorial. Each has an ID as a primary key. And for the module, because it has an coordinator, so it has a primary key coordinator is from the instructor. For the tutorial, because a tutorial belongs to a module, it has an instructor, so it has a module ID from module and the tutorial ID from instructor. We also has a module instructor table, which is for the many-to-many relation between module and instructor, where the module ID is a module from module and the instructor ID is from instructor. For question 3, refer to the class diagram of the design pattern developed in question 2 of tutorial 6. Map this class diagram to Java code skeleton, add implementation detail as necessary. For question 2, it's actually a strategy pattern. So the Java code is like this one. The point is here. For the location configuration, it has a method update network interface. And we have a listen network to listen whether the network is changed. And after the network is changed, it needs to update the network interfaces. So you call the location configurator update network interface method.